11-4, subtracting integers, and in this lesson you learn to subtract integers using models. When are you ever going to use this? Because knowing how to subtract integers can help you compare elevations when studying geography. So a parade had 18 helium balloons. 5 of the balloons were making their first appearance in the parade. How many of the balloons had been in the parade before? So we want to solve this by subtracting. So to answer this question, okay, you must find 18 minus 5. You can use a model of, you can model this subtraction problem using counters. Remember, you did this all the way back in second grade or third grade. You know for a fact that the answer is 13. Now that we are dealing with integers, we're going to have to find another method to find the difference because integers now will be dealing with positive and negative numbers. Okay, so you can model this subtraction problem using counters. So step number 1. Place 18 positive counters on the mat to represent 18 balloons, so that's easy enough. Okay, so 18 positive counters will be, let me remove this, that's your 18 positive counters, right there. Okay, so that's example number 1. Sorry, that's step number 1. Step number 2, since subtraction is the opposite of addition, we want to remove 5 of the positive counters from the mat to represent subtracting 5. Just exactly what you did in second grade. So we get that, okay, and then we simply get 5 of them, okay, and we take it out. So you get that 5 right there, this 5 right here, and we take it out of the mat, okay. So that represents 18 minus 5. This represents 18, of course. Okay, and then we know for a fact that with that we have 13 counters left, okay, which represents 18 minus 5 will give you 13. That's simple enough. So there were our 13 positive counters. This represents 18 minus 5 equals 13. There were 13 balloons that have been in the parade previously. Okay, so that's easy enough. And let's take a look at examples, and let's deal with more complicated problems. So example number 1, you can use counters to model subtraction problems involving negative integers. So let's use counters to model negative 5 minus negative 2. Okay, so now we're dealing with something we didn't do in second grade. Negative 5 minus negative 2. Place 5 negative counters on the mat to represent negative 5. So 1, 2, 3, 4, 5. That's step number 1. And step number 2, okay, remove 2 negative counters from the mat to represent subtracting negative 2. Okay, so we simply remove 2 counters from the mat. These 2 we take out right there. Okay, and finally step number 3, we simply count the number of remaining counters, which are 3 negative counters. So that means it represents negative 3. So negative 5 minus negative 2 is equal to negative 3. That's still pretty simple. Okay, let's take a look at the next example. So we added positive counters, all positive counters. Or sorry, we subtracted all positive counters, we subtracted all negative counters, and let's see if we can do a mix of both in the next example. So sometimes you need to add 0 pairs in order to subtract. So when you add 0 pairs, the value of the integers on the mat does not change. Okay, remember that when you add anything to 0, according to the identity property of addition, it will not change the value. So we want to use counters to find negative 5 minus 4. So first, place 5 negative counters on the mat to represent negative 5. So this is 1, 2, 3, 4, 5. So those are the 5 counters. And then step number 2, place to subtract negative 4. Okay, you must remove 4 positive counters. But if you notice, okay, there are no positive counters on the mat. Okay, you cannot remove 4 positive counters because there are none on the mat. So what you need to do now is you need to add 4 0 pairs to the mat. So you need to add 4 zero pairs, so that's 1 zero pair. Okay, this is another zero pair. Remember, a zero pair is a positive counter and a negative counter. That's a third zero pair and 4 zero pairs. Now, why are we adding 4 zero pairs? Because we want to subtract positive 4. And this is the only way we can put 4 positive counters on the mat, by adding a zero pair. Remember, when you add a zero pair, it does not change the value. Okay, so these are your 4 zero pairs. Now you can remove 4 positive counters. So what you do is you remove 4 positive counters from the mat. Okay, right there, these are the 4 positive counters that we will take out of the mat. So after we take that out of the mat, okay, what remains is the number of negative counters will be left. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So negative 5 minus 4 is actually negative 9. Okay, I hope that makes sense. Let's take a look at example number 3, and let's make this more challenging. In example number 3, one morning when Melissa woke, the temperature outside was negative 5 degrees. By noon, the temperature was 10 degrees Fahrenheit. Find the change in temperature. So again, this is a subtraction problem. So we want to first know the starting and ending temperatures. Okay, actually we already know it, the starting and ending temperatures. You want to know the change in temperature. So our plan is to find the change in temperature, subtract the starting temperature, which is negative 5, from the ending temperature of 10. So we want to use counters to find 10 minus negative 5. Okay, so we start off with 10 positive counters. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we start off with 10 positive counters, represent positive 10. To subtract negative 5, you must remove 5 counters. Okay, 5 negative counters. But you cannot remove 5 negative counters because there are none on the mat. Okay, so we have 10 minus negative 5, and if you notice, there are no negative counters on the mat. So what do? You must add 5 zero pairs. So 5 zero pairs on the mat, that's 1 zero pair, 2 zero pairs, 3 zero pairs, 4 zero pairs, and 1 more zero pair right there. So those are 5 zero pairs. So now you have 5 negative counters that you can remove. So we remove that. We get these 5 negative counters, and we actually take it out of the mat. Okay. And as you do that, you notice that, okay, there are 15 positive counters left. So this represents positive 15. So 10 minus negative 5 is actually 15. So the change in temperature is 15 degrees Fahrenheit. Okay? So another way of doing this, if we want to check if our answer makes sense or not, is that we need to create a vertical number line, which represents a thermometer. Locate the starting and ending temperatures. The number line indicates the change in temperature, which is 15 degrees. This is our number line right here. So we started at negative 5, we ended up at 10. Okay, and if you notice, if you look at the change in temperature, you have 5, 10, 15. Okay, positive 15. So the temperature is 15, so the answer is correct. The secret word is clock. Secret word is clock, and thank you for watching.